Alright, I am going to be going through the steps I did to create a smartwatch holder for my multi-board. And the first thing I did was I took the measurements for my smartwatch charger, charger diameter, depth, watch diameter, not really using that, lug offset, that's being used somewhere, and the border, which is the area around the thing. This is for the I find it much easier to put the sizes in here, and then when we move to the sketch, you'll see my sketch here. If I unhide it, we'll look at that. So I have, I started with a circle and the diameter of the circle for the charger diameter, which you'll see here, right there. Charger diameter is that circle. Then I used a guideline creating the watch diameter circle as a reference, and then I made another circle adding the border around the watch. So I had 3 circles here. I brought from tangent, I brought those down, I brought a tangent down here. I created the gap for the charging cable. All this time I'm only working on one side of the image with this, and then back up to here. Actually back up to here. Added the semicircle, and this was an arbitrary number. It just gets it so that there's enough room to pass through the charging cable. Then I would take and I used the mirror function. I selected the mirror line, which is the center, selected this, and these, basically just doing that. Adds all of those, copies them over to the other side, and with that you end up with a drawing. You know that it's a correct drawing because it's grayed on the inside, which means it's a solid space. Once we're done with that, I extrude it in 2 forms. First is I extrude it for the whole back plate, 2 millimeters. It's usually plenty. It doesn't have to be that. It's not going to get much stronger, making it any thicker. It's usually infill after that point. So 2 millimeters thick. Then I do a second extrude on the rest of the panel, using the same drawing. And that one is 8 millimeters, which happens to be the charger depth, as listed on the variables. So charger depth, with the starting offset, I use entity, and I choose the face of the first extrusion. Saves some math and makes it that much simpler. And merge, and it's an add, so you're merging with, so you end up with one piece here. Transient upright holder, which we named. Create a second sketch. This sketch is on the right side, and it is just the bracket. I just do that on the right plane, and it's fairly simple. It's just deciding that those are going to be 3 millimeter thick panels, 35 millimeters from the base to from the back of the plate to the panel I will be securing it to, and I will take and use the trim tool and cut the line here. These are just 2 corner rectangles stuck together. Then I'll take and extrude that, and the extrusion on this, I just use the up to face. So I took that face, add, extrude up to face. I chose to extrude up to this face, and then a second end position up to face. I flipped around and put it up to this face. let's get rid of these other sketches here. So I extruded them up to the face on each side. That gives us something that in the shadow here you can see that it's going to be the same width and a full size on the back here. There's always more than one way to do these things. I could have actually taken in, extruded another section from the original drawing, but I did not want to do that. So there's my, have to be extrude. I have my bracket, place for the charger, place for the cable a little bit. We're going to take care of that here. I'd like to add a little bit more. Okay, I guess the next phase is we're going to cut out the excess from this back panel, which we couldn't do earlier. So create a sketch using that panel, and it is using midpoint to line up with the disc. Actually, no. This disc is actually a projection. The center point of this is a projection of the origin of the system. So everything is using the same origin point. If we turn on the front, you'll see that everything is lined up with the origin point here. And the center of that circle is also lined up with that. It makes it easier. Get rid of some of these extra panes. So I created this drawing here. The easiest thing to do is when I opened up the drawing, I used the use project, and I projected as a guide this wall, and I projected this panel back here, the entire back panel here. And then I was able to hide the whole thing, and able to work in the middle of that, creating a 3-point circle using that origin point. We'll normalize it using that normal point and selecting the sides directly horizontal to it, and that gives us a nice tangent circle all the way around. And then I created another circle within that using the same center point. 22.75 is the diameter you need for the bolts in the MultiBoard system. For the large thread bolts is 22.75. So I just created a circle there. Then we'll show the upright holder again, and we just extruded. Shows those 3 portions of the drawing. Extruded them through as a remove, removing them from the upright holder. I could have made that, instead of a blind 25, I could have made it a up to next, which would do exactly the same thing, or up to face, and then chosen the face I want to cut it to. There are many ways to do the job in these. So we've got that cut. We'll hide that drawing. I did something else earlier, so I did not need this Boolean, so I'll delete that. Sketch 8. This is where I made the rest of the cutout for the cable to go through, clearance. So once again, I chose the face. It's this face here of the block. That was my drawing surface. I took and copied over, used project, the entire face, and then I just added a point corner, bring it from there to there. Gave it a distance of 15. Arbitrary. I thought it was aesthetic. Then I did a 3-point circle. Selected the midpoint of this line in each side, and to make it easier I used the trim and deleted one side of that line. So now we have, when you mouse over it, you'll see I have one continuous drawing all the way around, so that makes that a form. Okay, now I'll do an extrude. And you can see on the extrude, I just selected that section. Once again, I went blind 5mm, which I knew would be enough to go all the way through. I also could have used up to face or up to next. But anyway, it cuts it out. And you end up with that. After this, I decided I wanted to add some more supports. So once again, I chose the back plane here. And we'll split this, make it a little bit easier to see. So I took this, projected, didn't even need to project on this because I chose this as my back frame. I could have done this earlier in Sketch 7, but I didn't. I just used corner rectangles, draw it from the corner, give it a 6mm measurement in each direction, arbitrary number, just wanted to get some strength to it. And then I used the mirror again, choosing the right plane as my mirror, and then just selecting that to copy it over to the other side. Okay, now that we've done that, I move this down and I use the extrude function again. This time I'm using up to next to choose both of those faces in the drawing. We'll turn off the section view. You can see that would bring it all the way to the next part. So it gave me the bracing there. Now it's just to make it a little bit prettier. I had some fillets in the back that gives it strength, especially on the top and the back portion here. On the sides here, it just gives it a little more aesthetics. And those are, I use a 5mm radius for those. Another arbitrary number. And you'll notice that goes straight up to the edge of this cut. It doesn't cut into it. I'm going to add some chamfers. Chamfers are different from fillets. Fillets are round, chamfers are triangular. Triangles are much, the straight lines are much better when it comes to printing. I've decided that I'm going to print it on this surface here, which will reorient that later. So I want anything that's against the surface to have a chamfer on the edge, as that will that is better than a fillet. The chamfer doesn't have overhang problems. So in the chamfer, I chose the edges here and here, and here. Choosing this one automatically traces it all the way around to the other side. That's part of the tangent propagation. Same thing, chose the front, and it goes all the way around. Choose bottom two edges here, the edges here, 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 and the ones on the inside here. I just only had to choose one of those because it transfers around. I did not do anything on the back section here. This is going to be flat against the board. I don't need to relieve that at all. And I decided these are only 3mm thick, I don't need to do those. So those are 2mm 2mm distance chamfers. And then to finish it off, I transform, and my transforming I generally do using mate connectors. So I choose the item, the upright holder, transport by mate connectors, and there will always be a mate connector on the section that you want. So you'll take and you'll choose a mate connector on the part that you want on the bottom, which you'll see right here. I just chose a random. It could have been any of these, as long as that blue part is sticking out. That's the only thing that really matters. I could have used any of these, but I chose that one. And then I need to choose a 2 connector, and that 2 connector is going to be, it's easier to find it if we close that. That's going to be here. We want to make sure the front plane is on so we can, I'm sorry, not front. Top plane is the one we want to see here. So you want that with the blue post up. We'll unhide and see if that's the direction we want it. Yes, that is the direction we want it. If it was upside down, you use the flip primary access. And once that's done, this is always a courtesy to people who download the file, so that when they download the file, they don't have to do any reorientation. The file is already oriented for printing. And that's it. I'll throw in a quick time lapse of the print, and you'll see that printing. I also printed the large screw connector at the same time. It took a couple hours to print, but I start it and go to bed. Alright, and here we go with the finished product. Installed on the board. My watch is sitting on it, and it easily comes loose. You can see I set it in this orientation. It can go in any orientation. The watch easily snaps onto the magnet back, and it's held in place by some alien tape, and you can see that the watch is held in place sideways. And thanks for watching.